The curved rod has a radius of 5 feet. If a force of 60 pounds act at its end as shown, determine the moment of this force about point C. So today we're looking at this kind of odd curved shape right here with a force acting at its end A right there. And we know that cross products and moments are both path independent. So that means this curve right here could be any curve like this. Only thing that matters is the vector between point C and point A. So we can start with our find variable. Find variable today is going to be the moment about C. Okay, so we can start by finding the position vector from C to A. So it's going to be R C to A, and that's going to be defined as R to A from the origin minus R to C from the origin. Okay, I'm going to define these in the I hat, J hat, and K hat vectors. Okay, so looking from the origin right here to A, it's going to be traveling 0 in the x direction, the I hat direction. So we leave that blank, and we know that in the y direction, it's going to be positive cosine of 30, given that this angle here is 60, this angle between the A vector and the y-axis is going to be 30 right here. We know that radius is going to be 5, of course. It's going to be 5 cosine 30 degrees. And that's going to be in the positive j hat direction. Okay, and looking at the z direction, we're going to have a similar 5 feet. It's going to be using the component sine of 30 right there, and that the k hat direction right there. Okay, and that's all going to be in feet. Be subtracting the vector from R to C, from the origin to C, I should say. As we can clearly see right here, there's only one component here. It's simply going to be 5 in the k hat direction. Okay. And if we simplify that, we should simply get 4.33 j hat direction, and we should get negative 2.5 in the k direction here. Okay, and that's all going to be in feet right here as given in our problem. Okay, so next thing we're going to have to do, now that we have the position vector from C to A, is we need to find the force vector. So we're given the magnitude of this force vector. So we're going to find a force vector as that 60-pound magnitude, and it's going to be multiplied by some unit vector in the direction from A to B. Okay. We know unit vectors are just basically a direction. That's it. Their unit means that they have a magnitude of 1, so it doesn't affect the magnitude of the vector at all. It gives us direction for our magnitude. Okay, and we know that unit vectors are going to be defined as position vector to B minus position vector to A over the magnitude of the two. Okay, so we're finding from the origin to point B, from the origin to point B, it's going to be 6 feet in the I direction, 6 feet in the I hat direction, plus I think it's 7 feet. Yes, 7 feet in the j hat direction, and to be 0 in the k direction here. Okay, and we'll subtract position to A, and we actually already found that vector up here. We know it's going to be 5 cosine in the cosine 30, the j hat direction, plus 5 sine 30 in the k hat direction, and that's all going to be in feet right there. We'll look at the units a little more in a second. Okay, it's supposed to divide it by the magnitude of that. So we'll be using the Pythagorean theorem here, a big square root, and we're simply finding the magnitude in both directions. Okay, so if we add up the two I components, I should say subtract, because basically we're doing the vector addition here, and then we're squaring the two components to find the total magnitude. So we get it's going to be 6 squared right there, and since we have 0 right here in the I hat, the invisible 0 I hat right there, we'll be subtracting 0 right there. But you can also leave the 0 out there. I'm just kind of doing it to keep the form of the problem. Okay, in the j hat direction, we're going to have 7 minus 5 cosine 30 degrees. The j hat direction, square that. And lastly, we're adding the k hat direction. And since our first vector is 0 in the k hat direction, it'll be 0 minus 5 sine 30. Okay, and since the magnitude we can factor out is also going to be in feet, we can cancel the 2 because we know unit vectors are directionless. Okay, so that's going to be a whole unit vector, and we can change this to being our force vector if we multiply it by our magnitude of 60 pounds, a scalar magnitude, I should say. And we should get that force 60 pounds, if we split that up and multiply this down, I'll plug into your calculator, you should find it 51.23, the I hat direction plus 22.79, j hat direction minus 21.34 in the k hat direction right there. And that's all going to be in pounds. Okay, so now we found our force vector and our position vector right here. We can start taking the cross product, which should give us our final answer. The moment about C knows a vector is equal to the position vector times a force vector. Okay, we know its position vector is going to be from C to A, and our force vector is simply going to be there. Okay, so we can start by setting up a determinant, our 3 determinant. Start with the I hat, j hat, and k hat vectors. And we know that our vector up here is going to be 0 in the I hat, 0 in the I hat, 4.33 in the j hat. Let me double check, 2.5, negative 2.5 in the k hat direction. Write that. Our force vector similarly is going to be 51.23, 22.79. Running out of room, and they have 21.34. Okay, and just to do a quick sanity check with our force vector, you can see that our first two are going to be positive. The first two components are positive, and the third k hat component is negative. If you look at our problem, that does seem about right, because we know to get from A to B, we're going to travel in the both positive x and y directions, and then as we go back down to the xy plane here, we know that the k hat direction is going to be negative. So we know that we are in the right ballpark, basically, for the force vector. I always have to do a sanity check to make sure you're in the right general direction for those problems. Okay, and now we're going to solve this with cofactor expansion. So moment about C is going to be equal to, so the I hat component, we can cross out those two, the column the row is in, and we can simply multiply these two vectors. These two numbers, 4.3 is negative 21.34. Subtract and multiply these two numbers together right here. 22.79 multiplied by negative 2.5. And that's all going to be in the I hat direction. Okay. I'm going to start with the negative to j direction. Cross out our row and our column. we know 0 multiplied by anything is going to be 0. So we're going to start with the 0 right there. It's going to be subtracted by 51.23 times negative 2.5. Okay, and that's all going to be in the j hat direction right there. And then our last k component. Again, 0 to multiply by anything is going to be 0. So it's going to be 0 minus 51.23 multiplied by 4.33. And that's all going to be in the k hat direction right there. Okay? And if you plug that all into your calculator, you should find the moment about c should be equal to negative 35.4 I minus 128 j and negative 222 in the k hat direction. And the units for this are going to be in pound feet right here. I should say, really with the determinant right here, you're factoring out your units, and then it'd be in pound feet again, just to stay consistent. And there, we're going to find our final answer. To go back to check, that is our one find variable, the moment about point C. There it is, and we're done.